Hey everyone, welcome to Autocross Course Design 201, designing courses for tours, pro solos, and the national championships. The material that follows was developed by me and presented by Karen Babb and I at the 2019 SCCA National Convention. This video is an abridged version of what was an hour-long session, so if you need further details or clarification on anything, feel free to reach out to me. In this video, we'll go over what drivers expect at a national level autocross, and what they don't want, the parameters and constraints we have to take into account. We'll spend the bulk of our time talking about how to create a balanced course, and I'll share some ideas on how to get started. This presentation assumes that you have a grasp on the basic aspects of course design, and the goal is to give you some ideas and things to think about in order to design fun and balanced national level courses. I want to be clear though, there's no magic formula for designing a perfect autocross course. The best we can do is to take the time to understand all of the variables that we have control over and use those to the best of our ability. With that, let's dive in. The term course design can be misleading. The word design itself is misleading in that it invokes ideas of visual or graphic design, and it makes us think of our course designs as works of art. We come up with concepts and get very stubbornly attached to our designs. Any of you watching this who have some experience as course designers know exactly what I'm talking about. The thing is though, as course designers, we are not here to design a work of art. Our job is to create a product that is being used by many different customers who have paid good money and have certain expectations. They have not paid money to be wowed by our artistic genius. They have paid to enjoy and compete on a high-quality course. From that perspective, it is more helpful to think of course design as a product designer or a product manager whose job it is to balance customer needs with organizational constraints. All right. Think back to your all-time favorite autocross course. What did you like about it? What made it better than other courses you have driven? Take a moment to think about that, and consider the attributes that made that course great. I posed that question to the broader autocross community, and here's what they said. First, they expect longer and bigger courses. This makes sense given that most regions have to make do with much smaller lots than the amount of space that is typically available at sites that host national events. Second, and relatedly, competitors expect higher speeds than what they get at their local and regional autocrosses. This one is a bit nuanced in that we're still obligated to comply with SCCA rules and speed guidelines, not just for safety and compliance with insurance regulations, but also because the autocross classing system takes into account and assumes a certain speed range. Vastly exceeding that speed range wreaks havoc with the competitive balance between classes and within classes too. For example, in A Street, a Corvette and an Elise may be competitive with one another when the speeds are, say, 35 to 65 miles an hour. But that's not necessarily true when the speed range is higher at, say, 55 to 85 miles an hour. Next, competitors expect the courses to be balanced for different types of vehicles. We'll get into all of the reasons why that is important shortly. Competitors also expect courses to have a balance between being technical and flowing. These terms can be a bit ambiguous since different drivers use those words to mean different things. To some drivers, technical implies slower linked corners. To others, it means sections requiring patience. To others, it means sections that demand the highest levels of precision, and so on. On the other hand, for some drivers, flowing implies sections where you can maintain a higher average speed. For others, it is high-speed transitions. They expect a mix of different types of elements and visuals, sufficient line choice, and certainly safer courses. Finally, they expect courses that are easy to see but harder to figure out. Personally, I think that is the crux of a good course. A course should be easy enough to read that a driver of any skill level can easily find their way around the course, but should have interesting choices and compromises built in to reward a driver who is capable of analyzing and finding the areas to gain an advantage. Before we get to the fun stuff of how to build a course that has all of these attributes, let's take into account all of the constraints that we have. First, and most crucially, is the size and shape of the lot that we are working with. We can only do what the available space allows us to do. As grand as our ideas may be, we can't fit all of those ideas onto every lot. A long, narrow lot, such as a runway, is simply not going to be able to have the same types of elements as a larger, squarer lot. Second, every site has surface issues for us to work around. Even our beloved Lincoln Air Park is not truly a blank canvas. There are several bumps, jumps, cracks, areas of torn up pavement, etc., that limit what is possible, what routes we can take, and what elements we can fit onto the course. It goes without saying, we have to keep safety margins in mind. I won't go any further into that here, as I'm assuming that most viewers of this presentation are already familiar with the safety margin requirements. If you need more information about this, I suggest going through the SCCA Solo Rulebook and especially Roger Johnson's Course Design Manual. Often, the logistics of a site limit or fix the course entry and exit points, which may limit the direction and flow of the course. It is important to know that ahead of time so as to not be surprised on setup day. Having a suitable vehicle overlap is vitally important for national level events because there are a lot of cars that need to get through the course over a day. And the flow of the course design must allow for a suitably short overlap that allows for a good throughput or flow of cars, while also giving corner workers enough time to sufficiently cover the cones in their area. Speaking of which, corner workers should not be an afterthought. They should be an integral consideration of the course design. Unless completely necessary, try to avoid corner stations where the corners need to pay attention to something in front of them and something behind them at the same time. Or corner stations that are large enough where the next car enters the section before the previous one has left. It is imperative that the corner workers have enough time to tend to the cones in their section to avoid delaying the event or putting corner workers at risk. And then, of course, we need a plan for weather like this. Unless you are 100% certain that you are going to have absolutely perfect weather all weekend, taking all kinds of weather into account is an important part of your responsibility. Consider whether the elements, their spacing, and the course speeds are appropriate for all weather conditions. Parts of the course that may be completely safe in the dry have the potential to be really dangerous in the wet. Think through how a car will behave through the entire course in the wet. If at any point you find yourself saying to yourself, I hope it doesn't rain because I really want this element to work in this one special way, that should be a very clear clue that you are flirting with disaster. Try to figure out which areas of the site puddle up first, or perhaps the worst, and if possible, avoid those parts of the pavement entirely to minimize the effect of puddling on your course. Are the visuals such that they will be clear in the rain? Remember, it is much harder to see in the rain. There's water spray, it's usually darker, the reflections on the surface make the cones harder to see, etc. Have a plan for how to adjust the speed, direction, and attitude of every section without completely ruining their flavor. Alright, we're done with all the grim and boring stuff. Let's get into some of the more fun and exciting aspects of course design. Let's talk about balance. Why is a balanced course important? A balanced course is more fun and more fair. Autocross caters to an extremely broad variety of cars. Everything from the slowest Econobox to the fastest A-mod car you can imagine, and everything in between. So a balanced course is important to be fun for every type of vehicle that we need to cater to. Balance also matters for fairness of competition. There are several different types of cars in each class, and often completely different types of cars in the same class. An unbalanced course can end up completely favoring one of the cars in that class over the others, completely skewing the competitive outcome. And whether we like it or not, PAX or index matters too in some of the index classes, so balanced courses become vital to ensure fair competition. In trying to think of what makes for a balanced course, it is helpful to first think about the different factors that influence vehicle performance. You can slice vehicle performance in 1,000 different ways, but I think there are 5 main factors. the level of power, the level of grip, the size of the vehicle, the drivetrain layout, that is, front-wheel drive, rear-wheel drive, or all-wheel drive, and the vehicle's weight. Every car has some combination of these 5 attributes, and these attributes describe how the car might behave on course and affect what type of course it might like. So, thinking through that, we could ask ourselves, what type of course does a car like a Miata actually like? Think of Miata here as representative of any low horsepower car that is small and nimble. Take a moment to think about that. A lot of people think that a Miata thrives on small, tight and twisty courses. And while a Miata generally does pretty well on almost any course, when you consider the strengths of that type of car, where it actually thrives is on courses that have a higher average speed, where there's very little slowing down and a greater emphasis on speed maintenance. That is, a high-speed flowing course with few or no low-speed corners which it would struggle to accelerate out of. On the flip side, what type of course might a car like a Corvette thrive on? Typically, when people see a faster course, their automatic reaction is, "Oh, that's a power course and a Corvette's going to love it." Well, it turns out, not all fast courses favor a power car like a Corvette. If the course has a high average speed but does not give the opportunity for full throttle acceleration, it negates the Corvette's greatest strength, acceleration. From that perspective, a Corvette would thrive on courses that have slow corners with a lot of room to accelerate after those corners. It is important to understand the relative strengths of different types of cars, because we can only design a balanced course if we know what all the different types of cars actually like. While we have several different mechanisms through which to alter the balance of an autocross course, the most common way is through the use of transitional elements. The generally accepted principle is that the more transitions you have on a course, the more it will favor cars that rely on speed maintenance, and the more it will also favor cars that are perhaps smaller. While that's certainly true, it turns out that different types of transitions affect the balance to varying degrees, and thus it is not just a matter of whether there are more or less transitions on the course, but what matters very significantly is the types of transitions being used. Let's start with the middle row in this table. Our example cars are an ND Miata, which is approximately 68 inches wide, and a C7 Grand Sport Corvette, which is about 77 inches wide. When going through a regular slalom, a car has to move from side to side by its width plus the width of the cone. When measuring the distance the Miata and the Corvette have to move from side to side, the Corvette has to move 12% more laterally when going through a regular slalom. Now, if we look at an example like the top row in this table, where we have a more open slalom, that is, one that is offset in the easy direction by, say, 2 feet, the Miata now has to move from side to side by 44 inches, whereas the Corvette has to move 53 inches laterally. Now the difference is 17%. In other words, the more open the transition is, the more it favors a skinnier car. This should make intuitive sense in that if you imagine it at its extreme, imagine a slalom that is wide open to the point that the lateral gap is exactly 68 inches. It would be a perfect fit straight away for the Miata, while the Corvette would still need to move from side to side by some small amount. Conversely, looking at the bottom row, when we have transitions that are offset in the harder direction by 10 feet, the difference in lateral movement now is only 7%. The point of this is that not all transitions are created equal. We can use different types of transitions to alter the balance of a course by different amounts. Alright, so given what we've talked about so far, if we want to make a course more power biased, how might we achieve that? Well, we can make a course more power biased by allowing more unimpeded acceleration out of elements. By unimpeded acceleration, I mean having enough space and direction for a high horsepower car to use full throttle. If the corner exit is shaped such that only a low horsepower car can use full throttle, while the high horsepower car is using partial throttle, that is not unimpeded acceleration. Remember, the course does not have to have a high top speed to be power biased. It's not about top speed. Rather, it is about the ability to use maximum power. On the flip side, how might we make a course less power biased? Well, there are a lot of different things we can do. We can raise the minimum speed. This helps keep lower horsepower cars up in their power band, and more importantly, makes the speed range narrower, which limits the amount of acceleration needed. We could also utilize secondary characteristics of low horsepower cars. For example, generally speaking, low horsepower cars are also smaller, so we can utilize elements that favor smaller cars. A less commonly used technique is to use transitions immediately after a corner, spaced such that a low horsepower car can get through the slalom at full throttle, while a high horsepower car has to use partial throttle through the slalom before it can accelerate more ferociously at the end. This effectively gives the low horsepower car a longer straightaway than the higher horsepower car. One of my favorite techniques is the use of curved straightaways. I'll talk about this more in just a minute, but what I want you to take away from this is that making a course less power biased does not necessarily mean having a lot of cones or making it full of transitions. We have lots of other tools we can use to achieve the desired balance. Besides balancing a course for power, we may also need to balance it for size. And keep in mind, it's not just the width. Wheelbase matters too. As we've already covered, to make a course more friendly for larger cars, any transitions should be more of the deep offset variety rather than traditional slaloms, and we would have more longitudinal space between elements. Conversely, to make a course more small car friendly, we could use a more traditional or open slalom and utilize longer connected sweepers. As cars get more and more powerful and tire technology improves, we need to think of different ways to control speeds at an autocross. The most rudimentary way we can do this is to shorten the length of the straightaway. While that is certainly effective, that affects all cars an equal amount. For example, imagine we had a 30 mile per hour corner followed by a straightaway. Maybe a Corvette can get to 70 miles an hour at the end of the straightaway, while a Miata gets to 60. If we shorten the straightaway by some amount, maybe now the Corvette would get to 64 miles an hour, and the Miata would get to 55. But what if we only wanted to shorten the straightaway for the more powerful car? Well, turns out, we can do that. By using curved straightaways, we can affect the time and place that different cars reach their terminal velocity. Let's look at an example. This is the west course I designed for the 2018 Autocross National Championships. If you look on the map, at the bottom of corner 3 was the showcase turn, a hairpin turn of sorts, which was followed by a curved straightaway. What this ended up accomplishing is that higher horsepower cars would be able to accelerate at full throttle from corner exit up until approximately where the red arrow is. At that point, they would be at the speed needed to go around the remainder of the right-hand curve before needing to slow down for the next left-hander. A lower horsepower car would not be at the terminal speed for the right-hand curve by the time it got to where the red arrow is, and could therefore continue to accelerate full throttle past that point. In other words, the two types of cars ended up with different length straightaways. Both cars probably reached a similar top speed, but at different points along the curved straight. This is a very effective tool to allow high horsepower cars to enjoy the benefit of accelerating out of slow corners, but limiting the top speed they're able to achieve. Alright, with that, let's go over some general guidelines that encapsulate what we have just covered. Remember, these are just guidelines, not infallible rules. There may be exceptions to these, though most of the time they will hold true. As I said at the start of this presentation, there's no magic formula anyone can give you for a perfect autocross course design. Higher average speeds without exceedingly high top speeds will favor lower horsepower cars. More acceleration zones will favor higher horsepower cars. Allowing unimpeded acceleration at higher speeds will really help high horsepower cars. More sweepers will help race tires relative to street tires, and will hurt front-wheel drive and some all-wheel drive cars relative to rear-wheel drive. More transitions will reduce the race tire advantage relative to street tires, and will reduce the front-wheel drive to rear-wheel drive deficit. Long, high-speed sweepers will help smaller and lighter cars, and so on. So, now you know how to create a balanced course. So how do you go about actually creating your masterpiece? Assuming you have a blank template of the site you are designing a course on, the first thing, as we mentioned earlier about the constraints that we may have, is to take account of any of the fixed parameters, such as flows to and from grid, flow to impound, and if there are any restrictions on where the start and finish must be. In terms of actually designing the flow, I strongly recommend starting with placing the finish in the appropriate place first, making sure to leave enough safety margin in all necessary directions. Second, place the start in the appropriate place. Only then, fill in the rest of the course flow. Most designers like to draw a rough flow first, without considering actual elements or cone placement. This is just to draw the general path of the vehicle through the course. Other designers start by placing a few key elements on course, and then draw flows to connect those elements. I urge you to draw multiple flows and not get overly attached to the first one you do. For example, when I was designing the West course for the 2018 National Championships, I came up with 6 different flows before I picked one and built it out. It is important to not get too emotionally invested in any particular flow or design, and to make your decisions based on balance, length of the course, etc. Remember, we're not here to be artists. We are here to build the best product possible. There's another very useful course design technique I stumbled upon. Have you ever noticed drivers who, after completing a course walk, stand around with their eyes closed, wobbling from side to side, visualizing themselves driving the course? That is a great exercise to help improve your driving, but you can also use the same technique ahead of time as a course designer. For example, if you have your general route or flow drawn and are now trying to think of actual elements and cone placement, try closing your eyes and imagine driving off the start line. Make the initial turn through the timing lights, imagine the revs climbing, imagine your upshift, imagine what the car will be doing, and then ask yourself, what would be interesting to do next? It can be a really illuminating exercise to design a course this way, because you're doing it while imagining how a car will actually behave through your course. Continue to repeat that process. If you have imagined, say, a slalom, great. Now imagine leaving the slalom. What would be interesting to do next? And next, and next, and so on. To make a course more interesting and fun, consider trying the following. Utilize turns that are not all 90 or 180 degrees. 90 or 180 degree turns are very common at local events because they're very space efficient. And on typical smaller lots that local and regional events are held on, space efficiency is super important. But on sites that have more room, such as Lincoln and others, consider using turns that are, say, 60 degrees or 132 degrees or whatever. It gives drivers something new and unique that they may not have driven before. Second, utilize turns that are at different speeds from one another. This tests the driver's ability to find and stay on the limit and balance their car at different speeds, which is great fun. Create line choices. This should go beyond just making the course wider to allow for line choices. There should be genuine compromises built into the course, spaces where the driver has a legitimate and real choice to consider. There should be real pros and cons and compromises. The best courses have sections that offer a risk-reward element. This is important enough that I'll go a bit deeper into this in just a moment, but at a high level, there should be elements on the course that give the driver the opportunity to take a calculated risk in order to gain a chunk of time. The reward is essential. Courses that just have risk after risk after risk make the driver feel like they're tiptoeing around the course, just trying to prevent making a mistake. And finally, I recommend building sections that penalize drivers who may drive point to point, and reward drivers who look and plan ahead. We'll talk more about this too. Risk-reward elements are some of the most fun types of elements on an autocross course. They can take a variety of forms. It could be a gap to throw the car through. It could be a higher speed transition section that unsettles many drivers. It could be a challenging corner exit, and more. The general idea is that it involves approaching a section more or less in control, then going through a section barely in control to make it through to the other side with just enough time for recovery. The recovery section is where the driver gains the time reward and is absolutely essential. Building a course that emphasizes looking ahead is easier than it may sound. And to be clear, this is not about making a course harder to see. Rather, the course should remain very easy to see, but a driver who is not paying attention should be lulled into not optimizing the course as much as a driver who is paying attention. A common implementation of this is to have transitions where the spacing and offset change continuously. Only drivers who are looking ahead and have planned ahead will be able to sufficiently extract the maximum from that sequence of cones. Alright, we've gone over a fair bit in a pretty short period of time. For the sake of brevity of this video, I couldn't go quite as deep into each topic as might be needed. If you need any more information on any of this, don't hesitate to reach out to me. But in the meantime, here's our summary. A great national caliber course should be balanced for all types of cars, should present the driver with legitimate line choices and compromises to figure out, it should have a good range of speeds, incorporate sufficient risk and reward, and emphasize looking ahead. If you need to reach out to me, here's my email address. And for tons of other info on autocross driving techniques, the psychology of learning and performance, and more, check out www.beyondseattime.com. Until next time.